Now we have the section two-dimensional random variables. Before going to the session, we should know what is a random variable. We have already discussed random variables and also one-dimensional random variable. What is a random variable? Usually we denote random variables by capital letter X, and random variable is a function from sample space into set of real numbers. That is, we denote X as a function from S to R. And what is S? S is the sample space. And what is sample space? Sample space is the set of outcomes of an random experiment. Okay, so the random variable is a real number. So in one-dimensional random variable, we have discussed discrete random variable and also continuous random variable. As in the case of one-dimensional random variable, here we have two-dimensional random variable. Okay. So in two-dimensional random variables, we have two random variables x and y. So here we are given the definition for two-dimensional random variable. So in two-dimensional random variables, we have two random variables x and y, and it is defined on this sample space S. So it is a function from x cross y into from x. It's a function x cross y from S to R2. What is S? S is a set of sample space, as in the case of one-dimensional random variable. Okay, and R2 is the set of all ordered pairs. Okay, so here defined as xy of w equal to x of w, y of w, where w is an event from S. So this is the definition for two-dimensional random variable. So as in the case of one-dimensional random variable, here also we can define distribution function and also probability distribution function of two-dimensional random variables. So in two-dimensional random variables, we define distribution function. Usually we denote distribution function as which letter? Capital F. Okay. So distribution function is defined as f of x, y. And in the case of one-dimensional random variable, we define this distribution function or cumulative distribution function as capital F of x. Here it will be capital F of xy, which is defined as probability of x less than or equal to x, y less than or equal to y, where xy is an element of R2. This f is also called joint distribution function because there are two variables, two random variables x and y. So this capital F of xy is also called joint distribution function of the random variables x and y. Okay. Similarly, we define probability distribution function of two-dimensional random variables. We know there are two types of random variables, discrete random variable and continuous random variable. First we can define the generally probability distribution, whatever be the random variable is, even if it is discrete or continuous, the general probability distribution function is denoted by small f of x in the case of one-dimensional random variable. And we know what is f of x, small f of x, probability of x equal to x, capital X equal to small x. Similarly, in the case of two-dimensional random variables, capital we define probability distribution function as small f of xy, which is equal to probability of x equal to x and y equal to y. Okay, and we know the total probability of a random variable will be 1. So here we are given the definition for PMF or probability distribution function or probability mass function of a two-dimensional random variable x and y. F of xy equal to probability of x equal to x, y equal to y. And we know total probability is always equal to 1. So in the case of two-dimensional random variables also, we write total probability as 1. So in the case of discrete random variable, we define the total probability using summation sigma notation, and in the case of continuous random variable, we define the total probability in the case of integration using integration. So here, if it is a discrete random variable, we can write the total probability as sigma over x, sigma over y, f of xy equal to 1. Okay. So next is in the case of continuous random variable. In the case of continuous random variable, we define the distribution function or cumulative distribution function capital F of xy equal to in terms of integration. That is integral minus infinity to x, integral minus infinity to y, f of xy dx dy. And also the total probability, since the total probability equal to 1, we can write the total probability as integral from minus infinity to plus infinity, integral from minus infinity to plus infinity. Both integral are, one is integral over x and second one is integral over y, f of xy dx dy or dy dx equal to 1. There is the total probability of a continuous random variable. We know that's equal to 1. Okay, we can explain all this with an example. Okay, next we have an example. So in this example, suppose this is an example for discrete random variable. In this example, we have taken two fair coins which is tossed simultaneously. Okay, so you know what are the outcomes of a fair coin? When we toss a coin, we have two outcomes. One is head, other one is tail. So head and tail are the outcomes of a fair coin. So here suppose we are tossing two coins and we take x and y, the two random variables x and y as first random variable x is the number of heads or in the toss of the first coin and y is the number of heads in the toss of the second coin. So what are the values of x? So x means number of heads in the toss of the first coin. So when we toss a coin, that coin turns either head or tail. So if it turns tail, there is no head. So what is the number of heads? Number of heads equal to 0. So if it turns head, the number of heads equal to 1. So when we toss a coin, there are two outcomes, head or tail. If we get head, then the number of heads will be equal to 1. And if we get tail, number of heads will be 0. So x takes the value 0 and 1. Similarly, in the case of y is also a toss of the second coin. We get the same outcome. Y also take the value 0 and 1 because y is the number of heads of the second coin. So what are the possible values of the ordered pair xy? Ordered pair xy means value of x and value of y. So these are called the mass points. So what are the possible mass points? So the first coin can turn tail, then the number of heads will be, x value will be 0. At the same time, the second coin can turn tail itself. Then the first mass point will be 0, 0. Okay, and second mass point, suppose the first coin turns tail and second coin turns head, then what is the mass point? 0, 1. Number of heads in the first coin is 0. Number of heads in the second coin is 1. So 0, 1. Similarly, we have other mass points as 1, 0 and 1, 1. So the possible values for x and y, xy are 0, 0, 0, 1, 1, 0 and 1, 1. Now we have to find the probabilities of each at each mass point. So what is the first mass point? 0, 0. We define or we denote the probability at the mass point 0, 0 as f of 0, 0. So by the definition, what is f of 0, 0? F of 0, 0 equal to probability of x equal 0, y equal 0. And we know what is the probability of getting tail when we toss a coin. You all know the probability of getting tail is 1 by 2. And similarly, probability of getting head. What is the probability of getting head? 1 by 2 itself. Because only there are two outcomes. Okay. So F00 means probability of x equal 0, y equal 0. Which is equal to probability of x equal 0 into probability of y equal 0. That is 1 by 2 into 1 by 2 is equal to 1 by 4. So in the case of the probability of getting each outcome in the case of tossing a coin is same. So in this problem or in this example, the probability function or probability at each point will be same. That is FO01. FO01 is also equal to 1 by 2 into 1 by 2 which is equal to 1 by 4. Similarly, other mass points. Okay, so in generally we denote or we represent the outcomes or the probabilities of discrete random variable like as a table like this. So in this table we have two random variables x and y. X takes the value, here we have x takes the value 0, 1 and y takes the value 0, 1. So the mass points can be taken as 0, 0, 0, 1, 1, 0 and 1, 1. And the corresponding probabilities are 1 by 4, 1 by 4, 1 by 4, 1 by 4. Okay, we have already determined the values of probability. We just substitute the value probabilities in this table. Okay. So, and we have written one note in that definition that the total probability equal to 1. How will you get the total probability from this table? Total probability is just add all the probability values here. What are the probability values here? 1 by 4, 1 by 4, 1 by 4, 1 by 4. Adding these four probabilities, we get total probability equal to 1. So that equation is also verified, that is total probability equal to 1. Okay, so hope you all are clear with the concept. So thank you for this session.